Hey, Everyday Statistics. So good that you're watching today. Love that. Welcome to lesson 1.4. We're going to talk about stem plots, also known as stem and leaf plots. Awesome. So these are some things that we're going to do during our lesson today. We're going to make a stem plot. We're going to be able to interpret it, and we're going to be able to compare distributions with some back-to-back stem plots. So it's going to be a good time. All right. So, right, I've told you that sometimes you might have heard it called a stem and leaf plot, right? So what we're going to do is we're going to separate our data value into two parts. We're going to have a stem and a leaf. So this guy right here, right, this column is what I'm referring to as your stem. And this over here is what I'm referring to as a leaf, right? So I might say, hey, in the stem, we're going to put this, right? Leaves. I'll talk about how leaves can only represent one digit, but stems can be multiple digits, and we'll talk about how to do that. We're always going to arrange our stems in increasing order. We're going to go from lowest to highest. And we're going to do the same thing with our leaves, but we're going to go, lowest to highest in that direction, right? So we're going to go lowest to highest in this direction on our stems, and lowest to highest in the left to right direction on our leaves. Hey, really important that every time you make a stem plot, it must always include a key. All right, and the key should be, it should be in context. Whoops, if I can spell. It's not context, it can. No, it can't. No. Context is what we need here. All right. All right, so here are some steps for how you would go about making a stem plot. Okay, so if you want to pause it and put this in your notes, you can. I'm going to go through these steps as we create a stem plot together. And I just want to point out that, steps 2 and 3, we'll probably do all at once, right? We'll put them in the correct order. And then always add a key. Remember, if you don't add the key, it's not right. So that's also very important. We'll go through all these steps as we work an example here in a little bit. So one thing I might talk about doing here is splitting stems. So you'll notice that this stem here is this leaf area is quite long, right? For the stem of 0, you have this really long leaf. Well, if we go ahead and split that into 2 different stems, it makes it so that the data becomes a little more compressed and easy to look at, right? Because the whole point of making a stem plot is that we have a really nice way to see the shape of a distribution, right? We can look at the data fairly clearly with a stem plot. So how are we splitting this? How do we split this thing into 2 zeros? Well, this new leaf is going to be for 0 through 4, right? And then this one, right, this new leaf that we split off is going to be now 5 through 9. So that's how we will split the stems. And you'll see the same thing has happened with the 1, right? They took this data here and cut it off right there, right? So you can see that this piece that I was pointing out to you here now is that leaf. And then what's left, the stuff that is 5 through 9, becomes this set of leaves. So that is how we would split the stems of a stem plot. Fantastic. Look, there are tips to consider before you make in a stem plot. There's no magic number of stems to use. Too few or too many stems will make it difficult to see the distribution shape. 5 stems, it's a good minimum. If you split stems, make sure that each stem is assigned an equal number of possible leaf digits, right? So like what we did was we made it 0 through 4 and then 5 through 9. Those are equal, all right? We could also round the data. We'll look at that. Or another thing that you can do is use a back-to-back stem plot. So if I had common data, right, but it's separated by some difference, right? For instance, I asked some females, I asked some males, right? We wouldn't want to group those all together, especially if we're talking about pairs of shoes, and we'd like to know, hey, you know, does it look like maybe females have more pairs of shoes than males? We'd want to look at those two distributions separately if that was the case. And we'll do a problem where we're going to split the stems. We'll actually go ahead and create 2 different stem plots, and then we'll look at what the back-to-back stem plot looks like. I'm sorry, I think I said the word split, and I meant to say that we're making back-to-back stem plots. That's what's going on right here. All right. So I've been talking about working this example. Well, here it is. Let's do this. So we're looking at the many pairs of shoes. So we surveyed 20 females, 20 males from a very large high school, I guess, meaning that our sample is pretty big. And then we recorded this. Here we go. We got some data. Let's go ahead and make a stem plot. I'll do this on a new page for us so that we can stay nice and organized. Okay, so for this, we're going to be just sticking with looking at this female data. So here we go. Let's make a stem plot for the female. So let's go ahead and find our lowest value. It looks like the lowest value is, I think it's 13. Yes. So now we found our lowest value, and now let's find our highest value. It looks like it's 57. That's how we're going to plan what our stems need to be, right? Our lowest stem is going to be 1, right? And it looks like we have 20s, 30s, 40, and we're going all the way up to we have some 50s in there. So now we've got our stems. Let's go ahead and put in the leaves, all right? So we're going to start with all of the items that are in the range from 10 to 19, essentially, right? So we've got a 13, so that's that 13. That's that 13. We've got another 13 here. We have a 15. I think that's the next highest, right? Because we're putting these from lowest to highest. 15 and 19. All right, I think that finishes up that one. Let's go and look at what we've got going in the 20s. Looks like our lowest data value in the 20s is 22. We've got a 23. We've got another 23 right here. We have a 24 right there. And it looks like 2 26s. Beautiful. Let's look at what we've got in the 30s. We have a 31. Oh, my bad. We have a 30 and a 31. So we have a 30, a 31. We crossed that one out. A 34. And it looks like we've got this 38 here. Okay, in the 40s, it seems that we only have a 49. Okay. And in the 50s, we have a 50, a 51. There's the 50. Ooh, there are 2 of those. and then a 51. And lastly, the 57. Okay. Let's go ahead and make a key for this. So our key is that let's say that 2, 3 represents 23 pairs of shoes. All right, we'll put that in a little box. Awesome. All right, so in the question, we made this, we're asked to make it, right, a stem plot of the female data. Okay, we did that. Let's go ahead and describe the shape of the distribution for this female data. And what I kind of like to do in order to look at the shape is it's like I want to turn this thing over on its side so that I can get a better look at it. Let's do that. So I take this thing and I turn it on its side. Let's look at it like that. Then I kind of get a better look at the distribution. So I would say that this distribution it looks fairly symmetric, but maybe we'll go more towards it's skewed to the right. And I'm saying that because I think that these values right here are probably gonna drag our mean out towards them. So I think that I would describe this as skewed to the right. If you were gonna say that it's symmetric, and you had a decent argument for that, I think I'd go with that as well. We're not going to be able to tell really for sure without calculating the mean and the median and seeing if there's a big difference between the two of those. And we'll talk about doing that here in a little bit in the section where we're calculating those things. For now, it appears to be symmetric. You could also argue that it appears to be skewed to the right because of those high values there that I pointed to with the arrow. All right, let's look at what we got to do next. The next thing we're going to be asked to do is to explain why we should split the stems for the male data. And actually, what I want to do is go ahead and make the stem plot without splitting the stems, and then split the stems for you guys. So let's go ahead and do that real quick. I'm going to go ahead and take this female plot. Actually, let's go ahead and rotate it back, put it back where it was. Okay, well, I'm going to stash it over here. Hey, come back here. Behave. Stay right there. And we'll know that it's there because of the 6. I'm going to also erase this key real quick. This stuff. Let's go ahead and look at the male data. Here we go. I am going to go ahead and put that over here. Let's do it here. Let's look at them. Okay. Our lowest value is 4. But our highest value is 35. So one's a 1-digit number, the other's a 2-digit number. What are we going to do about that? Well, we're going to use our stem for our 1-digit numbers, and the 1-digit numbers is going to be a 0. And that's how we're going to deal with it. Our highest value is 35, so we're going to go 0, 1, 2, 3 will be our stems. The zeros will be any number from 0 to 9. The 1's going to go from 10 to 19, and so on. So we've got a 0, 4 for the males. Looks like we have a 5 here, a 5 here, a 5 there. Is that on my 5s? It looks like it. All right, let's get this 6 here. We've got a 7, and a 7, and a 7, and a 7. All right. Looks like that's all of our, oh, no, there is an 8. All right, and an 8. And that looks like all of the single digits. Let's go to the 10s. Looks like we've got a 10 right there, another 10 right there, another 10 right there, and another 10 here. Also an 11 and a 12, and a 14, and a 2. And that's it for the 20, or for the 10s and 20s. And then our next value we've got is a 35. Oh, and I said 35 was our highest, but no, wrong. Our maximum, or our highest value, is 38. All right, so the question is why would you want to split the stems? Well, I mean, in order to answer that question, let's go ahead and split them. So I just need the data that I have there. What we mean by split the stems is instead of there being 1 0, now there's going to be 2 zeros, right? This one is going to be for the values from 0 to 4, and this one is going to be for the values from 5 to 9. Let's go ahead and do that. So, well, this is 0 to 4 is just 4, right? And then this one will be anything from 5 to 9, which is 5, 5, 5, just copying down from up there. My values that were in the 0 stem that are from 5 to 9. So we're going to have a 1, 1 there, a 2, 2, and a 3, 3. And that's how we're going to split the stems on this one. Okay, so we've got from the first one in my stem here is 4 values from 0 to 4. So here we go, 0, 0, 0, 0 from my stem plot of top 1 to 4. It only has values. So I'm going to have to skip this one since there aren't anything 15 to 19 in my data set. There's a 2 here. I'm going to have to skip this one, right? And actually, I'll have to skip this one as well, because if we look, right, we have the values 35 and 38, but we don't have anything from 30 to 34. So this is going to be a 5 and an 8. And look at that. It looks much nicer when we split the stems. You can see that the data is actually fairly spread out, that those values at 35 and 38 are pretty extreme for the data. And I think it seems to be a lot more evident when we split those stems. All right, we'll go ahead and save that one and get on to the next thing. All right, let's check this out and see what we're asked to do next. We talked about why we need to split the stems. Let's go ahead and, so it's asking us to analyze this back-to-back stem plot that they have there. I'd actually like to create it for you guys. How do we make something like that? And then we'll go ahead and write some sentences comparing male and female distributions. Okay, so we're going to make that back-to-back stem plot. I'm not going to need this one anymore. We're going to split the stems on that one. So I think I'm going to put this over here. We're going to have to look at both of these that we've already created. And I think I'm going to put them over here. So this was the male split. And there's the females. I think we'll have enough room. Let's see. Didn't really like that happening. Okay, we'll leave that. No, that's not what I want to do. I just want to kind of make a little space over here. We're going to have to use these because they're all well organized, right? Okay, let's go ahead and make this split stem plots over here. All right. So over here, I think we'll put the female data here and the male data over here. And I think I'll scoot this over just for now. Let's look at the females first. So we're splitting the stems, right? So that means I'm going to have to go 0. Ooh. All right, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I'm doing this because we're going to be going all the way up to the 50s because of the female data. All right, so in my zeros, I'm going to put everything that goes from 0 to 4, and that's not a 1. I swear, it's just bad drawing. Okay, so 3, 3, 3, and now this one's going to get the 5 and the 9. There is, oh man, that is not good. See what my mistake was? Those values, these, that's it. There's the one right there. These values are tens, right? So that first one is 13, so it says 13, 13, 13, 15, 19. I put it in the wrong spot. So there's 13, 13, 13, 15, 19, 22, 23, 23, 24, 26, 26, 30, 31, 34. There's the 38. Just copying this over from this female data. I got to skip the 4. We're going to have a 49. We have a 50, 2 of those, a 51, and a 57. And there we go. We've got the female side of this going. Now we'll get the male side going. And because the stems are split, I can pretty much just copy this thing over onto it. And then we'll look at it and we'll talk about comparing these distributions. All right, so just copying this over essentially now, we have the split stems. So 5, 5, 5, 6, 7, 7, 7, 7, 8, 0, 0, 0, 0, 1, 2, 4. Don't really like how those didn't quite line up. Sorry about that. Then we got this 2 here at 22. We have a 35 and a 38. There we go. All right, let's write a few sentences about this real quick. Ooh, that wasn't cool. All right. So let's write a few sentences here. Remember, when we're describing a distribution, we need to always talk about every element in SOX. We need to talk about shape. If there are outliers, we need to mention center and spread. So let's do it. The shape of the two distributions. Oh, it's falling. Sorry about that. The shape of the two distributions appears to be skewed. Right, we've determined both of them were skewed, right? And we determined that about the female and the male distributions. The females, we looked at that, right, by turning it on its side earlier. All right. So we took care of shape. Let's look at outliers now. So we took care of shape. Now we're over here. The male distribution appears to have extreme values, right? But it doesn't look like the female data really does, right? So let's say that while the female distribution does not. Go ahead and just scroll up a little bit. Oop, and then all of these things that I threw over here are in the way. Let's get rid of them. female distribution. It does not. So now we have addressed talking about outliers. Let's talk about center. It looks like probably the center of the male data is going to be somewhere around here, while the center of the female data is probably going to be somewhere around there. So we could say that the center of the male data is less or lower than the center of the female data. Just comparing the two. And let's make sure that we have that is lower than the female data. The center of the male distribution, sorry, that's going to be the better word to use there. Male distribution is lower than the center. And then the next thing that we're going to need to talk about is going to be, you see the male distribution is going to be spread. Just being very thorough. All right. Let's talk about spread, variability, right? How spread out is this data? Well, it looks like the data has a fair amount of variability for both of them, right? They seem to be very spread out, right? These extreme values are causing a variability for the male distribution, and then if you look at the female distribution, it's fairly spread out. A range from 13 to 57 seems very, very large. Okay, so we're going to say that both distributions have a high amount of variability. Maybe not a high amount, have some variability. If I could spell ability. All right, we compared the shape, center, spread, and extreme values for both the distributions of males and females pairs of shoes worn. And keep in mind, I should have put a key here. We're going to do it. It's not done. It's not done. So remember my key. I had written it earlier for the females. So I guess I had checked that off my list. But let's say that, let's go with 3-5 represents 35 pairs of shoes. All right, we have done it. My key is in a box-ish. I don't know if you call that a box. It's an amoeba. Guys, we did it. Look at all the things you did today. You displayed some data. We got it all done. Look, Peacock says, thanks for watching. Thank you.